I'll go through and just read the question really quick, and then if I have questions for you on the question, I'll let you know.
Sounds good.
Okay, so we're writing two functions, flip that reverses the first k elements, and then I have to write a second function, pancake sort, that sorts an array only using that flip function. Okay. Okay, so I'm thinking I'm going to start by writing the flip function, obviously, because I have to have that to build out the pancake sort. Flip sort of the first k elements. Okay, so the flip function appears to be pretty straightforward. So I'm given an int array, it looks like, and then I'm just going to reverse the first k elements, and kind of the approach that I'm thinking is I'll start at the first, and I'll go from 0 to k, and it looks like it doesn't actually say, is k a 0th index or is it not a 0th index? Like, does it start at 1 or 0?
Good question. Because it says the first k elements, that means that it is 1 based, not 0 based. So you should watch out for that.
Okay.
Yep.
So I'm going to go from 0 to k minus 1 and then just swap. And actually, it's going to be, because I'm going to be swapping elements on the end, I'll only do that for half of that. So that way I don't undo the work that I've done in my swapping.
Right.
So that one seems pretty straightforward. The complexity space, it uses O of 1 because we're just going to use the input array. Time will be O of k, technically k divided by 2, but O of k. Okay, and I'm thinking maybe I'm just going to knock that out really quick before doing the pancake sort. So I'll go ahead. Is it okay if I go ahead and start writing that one up?
Yeah, sounds good.
Okay. So static, and doesn't say, I'm assuming that we're returning then back just an int array for this flip function.
I think you want to return whatever you need in order to use that within the pancake sort.
Okay. I think it might make more sense if we call this void and we just flip the input, basically. So we're given our two things here.
Okay.
And then I guess we have to consider edge cases. So if the array is null, what do I'm assuming we'll just want to return out. Does that work?
Yeah, I mean, if the array is null, then you just want to, there's nothing you can do.
Yeah.
So you, although I guess when we continue on, we can see whether we ever actually get an input that's null into flip.
Okay.
But I think that's a good thing to watch out for.
Okay. And then similarly, if the length is less than 2, we're just going to return. So if it's less than 1, or if it's 1, then obviously reversing it isn't going to do anything.
Right.
Okay, and this is going to be k minus 1 because it's a 1 index. Divide by 2. And now we're going to do swap. Let's see, and this one is going to be R of k minus I minus 1. And similarly, k minus I minus 1 equals temp. And I'm going to double check my for loop really fast. So consider if it's, let's see, of length 2. So the k that we're passed in would be 2 in that case. So this is saying go from 0 to 1, which is correct. So if it's 2, it will be 1 divided by 2, integer division. Actually, that would return 0. So maybe I have to reconsider this. So I'm thinking in the case of 2, so maybe this isn't actually k minus 1 divided by 2 here. So now if, in the for loop, we're going from k divided by 2, but we do need to include the minus 1 down here so we don't get index out of bounds exceptions. So we're good there. Okay, so that takes care of our flip function. So that's basically just reversing the first k elements in our array.
So before we continue, there is one little mistake in here that might trip you up later.
Inside of flip. Okay, let me look at it. Length. K divided by 2. Set temp at the first one. K minus I. So the cases where I'm thinking it might be an issue is here or here, more than likely.
Do you want to, I mean, we could walk through like a small example really quickly, maybe?
Yeah, and actually I think that I can kind of, let's go through an example. So let's consider one that's of length 3, I guess. So let's do 1, 3, 5. Let's do 3 at first. So this one is going to be, the call will be flip ARR, and then it's going to pass in 3, right?
Yeah.
Okay. So we enter in our loop. The for loop is going to go, so this is k divided by 2, and that's going to be, so that's going to be what, 1?
Mm-hmm.
Okay. So that's where the issue is. I see that now.
I don't think that's the problem.
So you don't think the problem's with the second part of the for loop?
I mean, I see a different problem.
Okay, so when I'm swapping, I grab the first one as the temp, and then the second one is 3 minus 1, which is index 2. So it would be swapping those. Divided by 2. Okay, so now I'm seeing
and then what happened?
Now I'm seeing that, this isn't a problem because we don't need to go twice. We only need to go once because it has a middle, right?
Okay. So why don't we keep going through this iteration here? What happens next?
Yeah, so in the first iteration, it would swap these two. So 5, 1. Now,
does it do that?
Let's see. I'll put it back. 1, 5.
So what happens in line 16?
I set R of 0 equal to R of 3 minus 0 minus 1, which is R of 2, which is then 5. So this gets set to 5.
And then what happens next?
And then the next one, R of, I see it. I was, that's a dumb mistake. I saw I as 1. That's an embarrassing mistake.
No, it's okay. It happens all the time. I just want to make sure it's working before we move on.
Yeah.
Okay.
Yeah, I's and ones look a little too similar.
Yep.
Okay, good. Okay, so now we get to consider the pancake sort, which is probably the trickier part of this question. Okay, pancake sort sorts and returns the input array. I'm only allowed to call the flip function.
You can only use the flip function to sort.
Right. So I can't. I mean, if I could just call arrays.sort, this would be easy.
Yeah.
Okay, so I have to think of a way to sort the array by reversing certain elements in the array. So let me just kind of think that one through for just a minute. So, and I'm going to do it by looking at their input at first, and then maybe consider some more examples after I've kind of thought
Yeah,
about it.
examples would be great for sure.
So I'm just going to look at the ones over there, and then for other examples, we'll write them out. But give me just a second. I'll try and make sense of it. So one thing I'm thinking, so start it off iteratively. So look at start at the beginning. So in this case, start at 1. You look at the next number, it's 5. The thing I'm seeing is reverse then from that number to the end. So it effectively, in this case, and I'll write it out. So it's 1, 5, and I won't do commas. 5, 4, 3, 2. So in this case, I'm saying we're going to reverse from 5 to the end. So 1, 2, 3, 4, 5. And then we'd have to check the entire array and make sure it's sorted. So that case is a little too perfect. So we'll look at some other cases. So let's say 1, 4, 3, 5, 2. So kind of the approach I'm thinking is, okay, start at the beginning. If my next element is greater than me, then I'm going to basically reverse it from that point until the end, and then move forward.
Okay, so do you think you could walk through maybe a couple steps, like what that might look like?
Yeah. So in this case, I'm at 1, I look at 4. 4 is greater than 1, so I'm going to reverse from 4 until the end. So 2, 5, 3, 4. Then in the next case, so this is where it gets, I guess, kind of tricky. So in the next case, I can't just assume that the second index is, perfect, which it turned out to be in this one. Let's see, 1, 2. Because right now, the way that I would have written this, it would say, okay, the one next to me is greater, so it would just continue flipping back and forth from here to here.
Oh, I see. Okay.
Yeah. So one thing I was just thinking, okay, so I'm going to flip. I'm not sure how if this would even be allowed. So let's say I flip and then verify that the next element is in fact the least of that section. You would basically iterate through that. That kind of screws up complexity pretty bad, though. So that I don't think that's going to be the approach that we want to take.
I think for now, let's not worry about complexity. Maybe we just worry about getting it to work.
Okay.
So yeah, what you're saying, like pairing all the elements together in an array, that's perfectly fine.
Mhm.
You just can't sort them without using flip.
Okay.
Yeah.
Okay.
Yeah. So if you want to search through the whole array, compare stuff, that's perfectly fair. You
Okay.
just can't move it around to sort it without.
Yeah. Okay. So that's an approach. So it's basically find the next smallest element. So it works kind of like a selection sort in that, okay, we're going to start at the beginning. We're going to find the smallest element in the array, and then I'm going to reverse such that the smallest element gets put in the leftmost index at first, and then you walk that over. That's an approach. I don't particularly like that though, because it's actually going to be worse than. Let's see. So we're going to have to find it, and then so it's still n squared, but we're doing a ton of swaps rather than what you have in selection sort, which is just the one.
Mm-hmm.
But that's an approach. So have I done a good job explaining that approach? Does what I'm saying kind of make sense?
Yeah. So just to reiterate what you're saying, you're going to, through the array, you're going to find the smallest element and then use the flip method in order to get that smallest element to the beginning of the array.
Yeah. And then after each time that you've done that, you move the beginning of the array over one so that you're not moving that lowest element.
Okay, and how would that work with the flip method?
So you find the least most and then call flip from our beginning index, whatever that is, it's going to start at 0, to the current least most index. So we'll look at this second example that I wrote out. And just to make this a little better, we're going to change it up. So in this case, 1 is the least. So we would call flip from the beginning to 1. So in this case, because it's not 0 index, we'd give it 4 for k.
Mm-hmm.
Okay, now I can kind of see the problem here. We're going to have to give it basically a subarray, because right now flip works for the first k elements. We can't tell it to ignore the first the first n elements.
Yeah, according to the problem, you're passing in the array, same array. Yeah, so you can only use the first elements. You can't bypass or do a subsection of the array.
Okay, so
you're always passing in the same array.
Right.
Yeah.
So that method, the approach that I was thinking is it doesn't work for putting numbers at the beginning, but it would work in the opposite way. So we could then place them at the end, and this would work just fine. So now instead of taking the least most, we're going to take the greatest. It'll still work for this example. So we look at this input. We see that 5 is the greatest. 5 is on the end though, so we don't have to move it. It's in its correct spot. So we make another pass, searching from here to here. We find that 4 is the greatest. So we're going to call pancakes, or we're going to call flip from. Okay, now I see. So we can't just say flip from 4, because that doesn't actually solve it right away, because it puts 2 in the wrong spot. Okay, so now I see. So we need to make 2 calls to flip in that case, right? So we'd have to flip from the beginning to the 4. So in this case, it'd be 2 and 4 I just wrote them in the same spot. 2 and 4. And then we'd have to flip from here to here. So that would become, so you're going to have 2 flips for every iteration, basically.
Mm-hmm.
So this one's going to be, what, 1, 3, 2, 4, 5. So then we do something similar in the next pass. So now we're only looking at these first 3 elements. So we see that 3 is the next greatest. So we're going to call flip from 0 to 3's index, which is 2. So now it's going to be 3, 1, 2, 4, 5. And then the next flip would be, let's see, 2, 1, 3, 4, 5. So that approach works. That works, but it's going to take, so we need, so iterate, and we're going to have 2 flips per position swap, basically. So to get the correct element into its correct position, we need 2 flips. So it's not very efficient. So I could write this up reasonably fast, but it's not going to be super efficient because we're going to have to do, we could potentially, let's see, well, so flip is going to take O of n. We've already said that. So it's still going to take O of n inside of my loop. So it looks like we're going to have O of n squared technically, because we're going to be iterating from 0 to n, and then inside of our loop we're going to be making 2 calls to the flip function. So technically it's still only O of n squared, but it's not very fast in terms of runtime because we're making 2 calls to flip. So that's one idea. Can we get any better than O of n squared with the flip function?
Not that I'm aware of.
Okay.
But sometimes someone comes up with something crazy. Yeah.
Okay, so that sounds like the approach that I'm going to take. Before I begin coding that up, do you have any reservations with that approach?
No, I don't. I mean, I'd love to see your code.
Okay. So similarly here, so we're going to add kind of the same null checks. So if the length is less than 2, then surely it's already sorted. So we're just going to return back the array. And if it was null, usually I would throw some kind of exception here. So that's something to consider. For now, we'll just return back the array itself. Okay, so we're going to iterate from 0 to the length. We're going to need a separate index, which will be the greatest element index, and it's going to start off as r.length minus 1 because it's an index. Let's see, so actually this isn't going to be O of n squared because I didn't discuss inside of our iteration we also have to find the next greatest element. I didn't consider that case. So actually it's going to be a loop on the outside. Do I actually even need? Yeah. So this is going to turn into O of n cubed.
How come?
So right now I'm thinking, so I have to find the next greatest element. So we're going to do this by performing a search from so this part's easy. I was just kind of thinking a way to maybe I was thinking of this wrong, this portion. So I'm going to have to search from 0 to the ending index, this greatest element index, find the greatest, and then perform flips on that. But actually, I think I can edit this so that this actually becomes... Yeah, okay. So I think that I do need something in here. So I have to effectively find the next greatest element. J less than. So now I'm seeing a way to simplify this. So I was moving in the wrong direction. So this is going to be I greater than or equal to 0. I minus minus. So now I effectively am going to keep track of the index on the end, the greatest index. And then this is going to be j greater than or equal to 0, j minus minus. So to find the next greatest element, I'm going to say, so I'm going to find the next greatest element in this loop. And we can just say R of I just to start it off. And then we'll need its, actually, we don't even, index equals. So what I'm effectively doing in this loop is I'm just going to go through and try and find the maximum element index for that iteration, basically.
Mm-hmm.
So if R of j greater than R of max element index, then we're going to set max element index equal to j. So at the end of this, we will have the greatest index, essentially. And then we can call flip. So first we're going to flip. We're going to flip the first. So I have to be careful because it's not 0 index. So flip the first. Flip that.
Mm-hmm.
So that's going to, like in these examples down here, where's an example? So like in this case, we're saying flip from 0 to 2.
Mm-hmm.
And then it's going to reverse those. And then we need to make the final flip at the end.
Right.
So this one's going to be flip to, it's going to be to I plus 1.
Mm.
Okay. Okay, so now I see where we're kind of like, it's not actually n cubed, so it is n squared. We're doing like 3 n squared n calls inside of the loop. So now I see that that's actually n squared. Okay, so let me run through this and just double check it for any errors and make sure that our approach is kind of right and that it's solving the problem we were initially tasked with. So we're basically, we've already verified the flip function, so we're good there. Pancake sort, we're going to start an index at the, this needs to be -1. I already see an error. So
good.
We're going to start at the end, go to the beginning, inclusive of 0. We're going to say the greatest element is on the end just to initialize it. And that greatest element is going to move with I, so that's good. And then we're going to loop from I, so now j, so loop from that max element, and actually this could be, well, no, I don't want to make it I minus 1. We'll leave it as I. So we're going to loop from here to the beginning of the array, basically, to see if there's any element greater than it. And if there is an element, so if r of j is greater than r of max element index, so if there's any element in this section that's greater than this one element, we're going to replace the maximum index with j, so the correct max index. So that works. And then lastly, we're going to flip from, so we've got the max element index. We're going to flip from the beginning, so that's what our flip function is doing, from the beginning to our max element index plus 1 because the index is 0th based and we want to correct it. So it's going to place the max element at the beginning, which is important. And then lastly, we're going to flip. So lastly, we're going to flip from the whole thing to I plus 1, similarly because I is 0th index, we need to correct to 1. So that would flip, like in the second case, it would flip from the second to last element to the beginning, moving the greatest to its correct position.
Okay.
Okay, that looks good. Anything that I missed?
It looks good to me. I guess the question is whether you want. We do only have about a minute left, so maybe it's worth just running the tests and just seeing if it works.
Oh yeah, I didn't even realize they included tests in here now. That's good.
Yeah, it's helpful.
Okay, good. Okay, awesome. They didn't used to have that. That's an awesome new feature.
Yeah,
so,
yeah, this
good.
one's new.
Good. Oh, I didn't.
Yeah.
I'm missing a return. So I need to just return back the array itself. Return ARR. Okay.
Okay. Let me try again. Oh, sweet. Okay. Awesome.
You didn't sound like you were very confident in it.
Well, I didn't. I don't work in Java, so I wasn't sure whether that static flip method was going to work without returning the array. But yeah, it worked.
Yeah. So Java arrays are passed. So everything is an object, array included. So when you pass in an array, you're passing in the object itself. So a reference to the object. So
interesting.
It works in place.
Okay.
It's a little bit different. So you. Like in C++, you have to explicitly say it. In Java, it's your always every time you pass an object. So yeah, cool. Okay, that was a cool problem. So we'll go ahead and switch.
Yeah, sure.
Okay.
Okay. I'm also going to switch to JavaScript because I don't work in Java.
Okay.
Or you probably don't want to see me code in Java. So okay. All right. So I'm just going to read through the problem. If you don't mind, and then I'll let you know how I understand it.
Okay.
Okay, so my understanding of this problem is we're given an array of non-negative integers, like in the example here, and then basically what we need to do is find the smallest non-negative integer that's not in the array. What's also really helpful here is that we've been given what the maximum value of an integer can be. So I guess one question I have is is it possible that we would have, is it possible you get an array that would be that would have max int number of elements, so then we wouldn't be able to find
the correct
smallest
solution?
Yeah.
Yeah. The problem doesn't actually clarify that. So let's assume that if we're given an array, there is a solution. So there
Okay.
is some element that's missing from that array.
Yeah, because that's a pretty massive array.
Yeah, that would be a very large array.
Okay. So I think let's see. All right, so I'm just gonna run through maybe a couple ideas here. I'm thinking I'm thinking that approach is some sort of greedy approach here, where we want to keep going through until we can find like maybe what the max number is, or sorry, I'm like, okay. Okay, so I think the first thing I have in my head is that maybe while we're going through the array, we're trying to see what's like, possibly what is the max number we've seen so far. And then also, the other thing we do also want to know is what is the other trick about this is like knowing what numbers we have seen so far. Because we don't want to, obviously we don't want to return an answer that is already in that array.
Right.
So right now, I know it'd be nice to find a better space complexity, but I think see whether there's some sort of hash map kind of thing going on here, where we want to know what numbers we've seen so far. But we ultimately only care about the smallest number we haven't seen. Okay. I'm also, I sort of want to come up with a better example than what's in here right now. So say we have 0, 3, 4, 6. 1 would be the solution here. Okay. So let's see. So if we and I'm also questioning how a hash map would help this too.
I think your intuition was good on that. You need to keep track of what numbers you've seen. That sounded like kind of your idea behind using the hash map.
Yeah, I'm just trying to think about, like, I don't want to get into a situation where I'm like having to go through the whole hash map to figure out what the smallest number is that isn't there, like sort of like what's the best way to use that hash map to get the answer I want. Okay. I want to think about if I'm going through this array, hopefully in an ON way, so we're just iterating once, how would this work? Okay, so if I see 0, then we know that 0 can't be the option. So if I store that in the hash map, and then if I see, and then the next time I see 3, and 0 is the smallest number I've seen so far, and 3 is the highest number I've seen so far. Okay, so if we have a min right now of 0, and we have a max of 3, basically we know that the smallest number has to be between 0 and 3. And then we go to 4, but 4 is more than 3, so that's not going to help us unless we put that in the hash map. because at some point the problem is like, what if we do find, so what if at some point this array actually has 1 and 2?
Mm-hmm.
Then we start getting into a messy situation here.
Yeah.
So if we get to 1, then we know the min number we've seen is 1. And then at some point, the min number we'll see is 2.
So I think you're saying like trying to use this like min-max approach, it does get very tricky pretty fast. So like if all of a sudden you meet all the conditions and now min and max, all the numbers in between have been included, it gets a little tricky. So maybe try and think of just maybe a different way that uses your hash map to determine if some number between, I don't know, 0 to max isn't in there.
If a number between 0 and max isn't in there. Okay, so I guess we're saying if we say hash of okay, so if hash so if we see, okay, so we have a min of, we have a min of 0, and then we have a max of 3. And then we want to, but at some point this could change. So we know that we have, if we know we have 0, the hash of 0, that would be true, but I feel like I want to store something else in here. So when we have a hash of 0, or so yeah, I'm wondering whether like this hash whether we really need to be storing like 3 values or 3 things here, like whether we're storing what the current I guess min max we've seen, which is here in this case when we first go, and then it's a max of 3, but then at some point we're going to be at a min of 2. And if this array is longer, like say we go here, or we even go here, like how do we adjust this?
Yeah.
Let's see. Let's see.
So maybe we can step back and try and simplify the problem a little bit. So right now you're kind of thinking through, which is good, like this min-max situation.
Okay.
What if instead we just consider like, okay, we hash it at first, and then we just need to somehow find what the smallest element that isn't in that hash. How would you go about doing that? So like if you just hash the whole thing at first, so you're left with some set of all the numbers. Like what's an approach that you might take to find the smallest element that's not in there?
Okay, thanks. So I think what you're saying is that we would do this hash approach where I would just be like hash of 0 equals 3 or equals true. And then once I hash the whole array, I would just start from 0 and then just keep incrementing until I get to a point where the number isn't in the hash.
Yeah.
So for instance, okay. Yeah, I think that's like that would be that could work. I think, do we know what like the length of the array could be?
We can assume that it is smaller than the max int, basically. So that
Okay.
covering that case at the beginning where we said, because all the
Okay.
elements are unique, we can assume that it's smaller than max int in size.
Okay, so that would make the hash map potentially very large. As we talked about before, the array would be really large at that point. And that could also make the runtime massive as well, where we could potentially be going basically the length of the array twice.
Right. But what's the complexity of kind of the approach we're thinking?
So if we think of the number of elements in the array as n, that means that the runtime would basically be O of n plus incrementing up the numbers until we find the smallest number that isn't there, which could be we could be as large as n, like the examples n. So that would be a runtime of basically, I mean, it's 2n, but basically O of n.
Right.
And then the space complexity would be O of n if we're creating that hash.
Right. And in terms of time, can we do any better than O of n?
I mean, I think that's why I was trying to see if there was a more greedy approach of doing this. Whether there's a way to keep track of like the min and the max that we've seen so far, because that potentially, if we have that kind of track, then we might know the range that we have to look into instead of like having to start all the way from 0.
Right.
Yeah.
And I think you kind of saw the problem with that approach was like, as this guy continues to get longer, you don't really know what's towards the end, right?
Yeah, and it's gonna change over time.
Yeah.
Yeah.
So what does that tell us? Kind of like what do you think our best case then is? Like what's the fastest we can do this?
I mean, I know we definitely have to do O of n, like there's no question about that. Yeah, and I think because I'm having trouble with this like max, like storing the max and the min. I think the best approach is going to be to have to go again from 0 and then keep incrementing until we find that number. Just because the array could change over time.
Good. Yeah, I like that approach. Maybe we can try and pull that up. And then it says towards the end, if we have time, we can consider if we can edit the array itself.
If we can edit the array itself. Okay. Yeah, let me code this up just so we have something that's working that we can modify. Okay. Yeah, the other thing that could potentially work also is using a set. But I'll just do a hash because I'm more comfortable using that. But in JavaScript, sets are kind of a newer thing that can actually perform a little faster than hashes. Okay. Oh, whoops. All right. There's like a delay between me typing and.
Yeah, that makes it hard.
It's like, I swear I know how to type. Okay. Okay, so the first iteration, we're just going to be adding to the hash. So basically, and okay. And then in the next part, and let me just put this here. Let the call it, let the number equal 0. Okay. And then we're going to have, and then we had this constant, which I sincerely doubt we'd ever reach, but let's just be careful about that. Oh, and this is, as I said, okay. Right. -1. Okay. So while this number is less than or equal to max int, okay, if this number is not in here, I'm going to return. Otherwise, we will keep incrementing. And then if this ever happens, which is kind of weird, yeah, if we ever get to the point that we've gone through all the numbers until we get to max of int, I think normally I'd throw an error because that's just really not right. So I will just throw an error here because this is something that someone should be really looking into. There's something really not right here. So like went beyond max int. Okay. Okay. And okay, so I think that would get us the answer. Let me just double check with an example. So let's say that we have, I guess we can just, I want to do like a slightly different example than what they're giving. Let's see. See that. So we know that the answer should be 2. So in the first case, I is going to equal 0. And that means that our num hash at 0 is going to be true. So let me just do this. I'm going to do it this way. Okay. So then this is not doing this correctly. Okay, so that means that 0 would be true. And then in the next case, our index is 1 and the value is also 1, so 1 would be true. And then in the next case, our index is 2 and that our value is actually 3, so 3 would be true. And then the last case where the index is 3, that means that that's 4 and 4 would be true. Then in the last part, we're going to start with our number is going to be 0. And 0 is in the hash, so we're going to increment the number. Then the number is still in the hash, so we increment again. And then we see that it's not in the hash, so then we would return 2. Okay, cool. Okay. So did we, is it okay to move on and try the last part of this?
Yeah. So the last consideration is considering if you were allowed to edit the array itself in memory.
Okay. How would that help us? Okay.
So just trying to reduce our space complexity.
Yeah. All right. Let me, I'm going to do this because I think that array is too long. Okay, so if we were able to modify the array, how would that help us? I'm guessing, I guess one thing that would help is if we could just sort the array, and then we would be able to just start at the beginning of the array up until the point where we find that a number isn't there anymore.
Yeah, so that's one approach. So what's the complexity there, space and time?
So if I'm just using the JavaScript sort, that's going to be an n log n runtime complexity. And then obviously we wouldn't need the hash map anymore. So there wouldn't really be a space complexity to worry about anymore.
Okay, so that's one approach. So maybe there is some kind of trade-off where we say, okay, maybe we're constrained by the amount of memory, and n log n is still fast enough for us. So we say, yeah, that's good enough. But for this problem, there does exist a solution which is ov(n) in time and ov(1) in space. That's what we'll try and hit.
Okay.
And
Okay.
it is kind of based off of a sort, so good intuition there.
Okay. All right. So let me think. So, okay. So my guess is that there's some sort of like swapping going on here. So let's see. If we start 0, 3, 1, 4, we start at 0, and that's the min that we've seen so far. And then we go to 3. We go. So 0 is the min we've seen so far, and then if we go to 3, we know 3 is larger than 0. And then we go to 1, and we know 1's less than 3. So we might want to swap 1 with 3. I mean, I think ultimately, like, what I guess if like the reason I thought of sort is because like ultimately I think what's really valuable in modifying the array is to do what we're doing with the hash in line 14, where we can just keep incrementing and going through. Mm-hmm. So the question that's going through my head right now is like, is there a way to like an ON way that we can just like start getting this array into this form where it's sorted? Let's see.
So because we're kind of time constrained, we'll just go over like ideas. We don't have to go through and try and implement it. Okay. And I'll give you just a couple of small hints or try and probe some. Okay. So like given that example that you're looking at there, that second one, what approach would you use to actually determine the least most number that's not in the array?
I guess if we how would I determine the least most?
So what do we notice in this case? So what's the answer in that case?
We know it's 2.
And do you see anything special about maybe the number 2 there?
Well, yeah, so the number 2, so up until the point we get to 3, the index matches the number. So 0 matches 0 and 1 matches 1. So, okay, so I think my intuition before about swapping might have been right in that case. So maybe that like we would just keep swapping. So if I guess in the first example here, we see that 0 is at index 0, so we leave it. And then when we get to 3, we can see that 3 is not at the rate, it doesn't match its index. So then we could move it to 4. we could swap with 4, and then we see 4 is not right, and so on and so forth, and keep swapping until I guess we're done with swapping, and then go up from the beginning of the array until we find the spot where the index doesn't match. It doesn't match the number.
Yeah, good.
Okay.
Yeah, that's basically exactly the approach. So
interesting.
You'd think, and they actually mention this, and maybe you can read over it at the end. But they mention this. So if you look at the code intuitively, it looks like it's O of n squared. But if you actually go through some test cases, you end up only doing O of n. You do n swaps, so it ends up being O of n, which is really, really nice. It's kind of a cool
interesting
solution. Yeah.
Yeah.
So, and actually, you could probably. I mean, we have a couple minutes. If you want, we can try. If not, it's fine. I think you came to the like correct approach just talking through it. So I think that's good enough.
Okay, cool.
So good. And you jumped through to this approach using the hash very quickly. So that was good to see. And maybe should we try and run the tests on that if they provide them?
Yeah, let's see. That's one thing. Yes, test my code.
Yay!
Yay! Okay. Awesome.